Hello students, welcome to today's lecture on theory of machines. Today we'll discuss the classification of followers. In the previous lectures of this topic of cam and follower, we discussed what is a cam and follower mechanism and why it is required and what are its utilities. We also defined cam and further discussed about the advantages of cam and follower mechanism. In the second lecture of this topic, we discussed the classification of the cam depending on the various criteria like motion of the cam, shape of the cam, motion of the follower, etc. and their uses, advantages and limitations. We saw in details the radial cam, wedge cam, cylindrical cams, conjugate cams, globoidal cam, both concave and convex, and we saw the spiral cam, the spherical cam and the end cam. We also discussed why we use springs in case of cam and follower mechanism and why we use cylindrical cams or the cams having groove cut on the surface. Having discussed all this, let's move ahead with the classification of the followers. The followers are classified on the various criteria. First, on the basis of the movement, they are classified as reciprocating follower and oscillating follower. Further, according to the shape, they are classified as knife edge follower, roller follower and mushroom follower. Mushroom follower is further classified as flat faced follower and spherical faced or the curved faced follower. Further, according to the location of line of movement, they are classified as radial follower and offset followers. This is the basic classification of the followers. Let's see them one by one. Let's see the reciprocating follower. This is a typical reciprocating follower in which the follower motion is reciprocating or translating in the vertical direction. According to the shape of the cam, the follower is moving up and down with the help of a spring so that the contact between the cam and the follower is always maintained. The reciprocating motion of the follower is always between the guides. Next, we see oscillating follower. In oscillating follower, the follower is pivoted at a suitable point on the frame and oscillates as the cam makes the rotary motion, as shown here. In this, the end of the follower is placed inside the groove, and as the cam is rotating, the follower is oscillating according to the profile of the cam. Moving ahead to the next classification based on the shape of the follower, we have knife edge follower. So this is a typical knife edge follower. It is quite simple in construction. However, its use is limited as it produces a great wear of the surface at the point of contact. Next we have roller follower. This is a roller follower. You can see that roller follower has a cylindrical roller free to rotate about the pin joint. That is, the roller of the roller follower is making the revolute joint with the follower. The roller of the roller follower is always in contact with the profile of the cam. This is the widely used follower. At low speeds, the follower has a pure rolling action, but at high speeds, some sliding also occurs. In the case of steep rise, a roller follower jams the cam and therefore is not preferred. Next we have mushroom follower, which is again classified as flat faced follower and spherical faced follower. So let's see the flat faced follower. This is a flat faced follower. You can see the surface of the follower is flat. This has an advantage that it does not pose the problem of jamming the cam. However, high surface stresses and wear are quite high due to deflection and misalignment of the flat-faced follower. These disadvantages are reduced if a spherical faced follower is used. So you can see that the surface of the follower that is in contact with the cam is of spherical shaped or curved shaped. So this basically reduces the problem of misalignment and deflection, and this also does not have the problem of jamming of cam. Moving ahead, We have next classification based on the location of the line of movement, radial follower and offset follower. So let's see the radial follower first. So these are the typical examples of radial follower. The follower is known as radial follower if the line of movement of the follower passes through the center of the rotation of the cam. So you can see in all these cases, the line of movement of the follower is passing through the center of the cam. So all these are examples of radial followers. We have offset follower. So this is example of offset follower. In offset follower, if the line of movement of a follower is offset from the center of rotation of the cam, the follower is known as offset follower. As shown here, the line of movement of the follower is at a certain offset distance from the center of rotation of the cam. You can see here, this is the offset distance. So this is how typically the followers are classified depending on the motion of the follower, shape of the follower and the line of motion of the follower. I hope you have understood the various classifications of the follower. So this is all about today's lecture. In the next lecture, we will see the various terminologies that are used in cam and follower mechanism. Thank you.